Okay, now we have to do conversions from binary to decimal, decimal to binary, then octal to decimal, decimal to octal, hexadecimal to decimal, decimal to hexadecimal, hexadecimal to octal, octal to hexadecimal, binary to octal, octal to binary, octal to hexa, all interconversions. Anything can be asked in the exam, so you should able to know the basic logic behind how to convert from any number system to another number system. Right? Now the first part will start. That is how to convert any binary number into a decimal number. Okay? So binary number, any random number I am writing. I don't know what is its equivalent decimal, right? And I should write it like this way. Then only it will indicate that it is in binary. Otherwise, it can be pronounced in different way in decimal number system, like 10,000. Okay. So you should mention its base. So 2 indicates it is in binary. Now I'll show you how to convert it into decimal. The base of this number system is 2. So simply go on multiplying by increasing power of 2 towards left hand side. So this will be 1 into 2 raised to 0. This 1 into 2 raised to 1. This 1 into 2 raised to 2. Then this is 0 into 2 raised to 3. And 1 into 2 raised to 4. Out of that, this is 0, so we don't want this. 2 raised to 4 is 16, plus 2 raised to 2 is 4, plus 2 raised to 1 is 2, plus 2 raised to 0 is 1. So 16 plus 4, 20, 22, and this one is 23. So this is 23 in decimal. The very simple way to convert this is, there is no decimal point yet, we have discussed, right? So this is an integer. Directly go on increasing towards left in the increasing power of 2, and finally add it. Only discard the number which is representing you 0, right? Because 0 into anything will be 0, so this will be 23. Is it clear? Okay, we'll go. Or another way, the shortcut method is 1, 2, 4, 8, 16. Right? 8, 4, 2, 1 code. Discard 8 and add the remaining numbers. Okay. But you can't use this method in the exam, right? So you have to use the normal method of multiplication. Now, one more example we'll see. 101. Now I am giving a decimal point 0101 to the base of 2. So here is your decimal point. Here go on increasing the power of 2, and here go on decreasing the power of 2 on right hand side of the decimal point. So here this will be already we discussed this part. Here it is a decimal point, and now 0 is there. So 0 into 2 raised to minus 1 plus 1 into 2 raised to minus 2 plus 0 into 2 raised to minus 3 plus 1 into 2 raised to minus 4. So this will be 4 plus 1, that is 5. Point. Now this is 0, so I'll discard this. This is 0, I'll discard this. So this is 1 by 4 plus 1 by 16. Okay, so even if I find out the LCM of this, it will be 5 by 16 or so. So whatever comes, you can do this. So 0.31 approximately it will come. So it is 5.31 in the decimal. Right? Is it clear? I'll post few numericals, like 2-3 numericals based on this, or you can take random any number in binary and try to convert it into decimal. Now we'll go for another conversion. That is decimal to binary.
Go.
Now second conversion we'll do, that is decimal to binary. So take any decimal number, say 35 I am taking, and I have to convert it into binary. Okay, so here in previous method when we converted binary to decimal, we multiplied by 2. Here now we have to divide by 2. Okay, so I will divide it by 2 and I'll write the remainder on this side. Again the remainder on this side, the remainder on this side, the remainder, this is a remainder, right? And again if I divide it by 2, this one will come here as remainder and the quotient will be 0, and then I have to write it in upward direction. So this will be 1, 0, 0, 0, 1, 1 is your binary equivalent of 35. You can cross check it. 1, 2, 4, 8, 16 and 32. 3 zeros are there, so I'll discard these 3 numbers below them. And if I add it, 32 plus 2, 34 plus 1 is 35. That means your conversion is correct. Right? Got this? Just note down this. Now we'll take one example which will have fraction also. Okay. So take any number. So 23.46 in decimal. Okay. So there are different methods to convert integers into binary and fractions into binary. So first is 23 I will convert the way which I just now explained. Something is wrong here. This is 10111, the conversion of 23. Now we'll see how to convert 0.46 into binary. So 0.46, this is in decimal. So you have to go on multiplying by 2. So if I multiply it by 2, this is 0.92. So I will take this 0 here. I'll write that 0 here. Then again 0.92 into 2. So it is 1.84. So I'll write this one here. And again I'll take 0.84 into 2. Again I'll take this one there. 0.68 into 2. Again I'll take this one, right? So this will keep on, we have to keep on doing. So we will limit to 4 bits, and then the important thing you have to remember is you have to write the numbers like this from upward to downward direction. So this is 0, 1, 1, 1. So this is a conversion of 0.46 like this. Right? It's very simple. Go on multiplying by 2. Whatever comes on the integer point here before decimal, copy it here. If 1 comes here, write it 1. If 0 comes, write 0. And then limit to 4 bits. Right? So we finished with decimal to binary.